Everyone's heard the term large language model. ChatGPT is one, Claude is one, Gemini is one. They are the engine behind basically every AI product you have used in the last 2 years. But if you asked most people to explain what a large language model actually is, you would get a lot of vague hand-waving about AI trained on the internet. So in this video, we are going to explain exactly what an LLM is, and the reality is genuinely stranger than most people expect. Let's start with the misconception, because it's the most important thing to clear up. When most people use ChatGPT or Claude, they assume the model is thinking, reading your question, understanding it, reasoning through it, then answering. That feels like what's happening. But that is not what is happening at all. And once you see what is actually going on under the hood, you will not be able to unsee it. At its core, a large language model does exactly one thing. It looks at a sequence of text and predicts what comes next. That is the entire job. Predict the next token. Predict the next token. Predict the next token. Everything you have ever seen an LLM produce, every essay, every block of code, every conversation, is the result of that one operation, repeated thousands of times in a row. Now, what is a token? A token is not exactly a word. It is more like a chunk of text, sometimes a full word, sometimes part of a word, sometimes just a punctuation mark. The word unbelievable might get broken into 3 tokens: un, believe, and able. Models use tokens instead of whole words because it lets them handle rare words, names, and different languages without needing a separate entry for every possible word that has ever existed. When you type a message to an AI, the first thing that happens is your text gets converted into a stream of tokens. The model never reads words the way you do. It reads numbers. Here is why tokens matter more than most people realize. Because models think in tokens, not words, they can behave in surprising ways around language. Ask a model to count the letters in a word, and it often gets it wrong. Not because it is bad at counting, but because it never sees individual letters. It sees tokens. The word strawberry might be a single token or split across 2. The model has no reliable way to inspect individual characters the way you can by just looking at the word. This is a direct consequence of the token architecture, and it is one of those quirks that reveals something important. The model processes language in a fundamentally different way than humans do. It is not reading, it is pattern matching on chunks. So back to the core mechanic. The model reads tokens and predicts what comes next. But here is where the word large starts to matter. To get genuinely good at predicting the next token, the model needs to read an almost incomprehensible amount of text. Books, websites, academic papers, code, Wikipedia, news articles, a significant chunk of everything humanity has ever written down. Learning from all of that requires a massive neural network with hundreds of billions, sometimes trillions, of what are called parameters. Parameters are the numerical weights inside the model that encode everything it has learned. Think of them as billions of tiny dials, all tuned through training to make the model better at its one job. To give you a sense of scale, GPT-3, released in 2020, had 175 billion parameters. That felt enormous at the time. Models in 2026 are estimated to have trillions of parameters. The compute required to train these models is so significant that only a handful of companies in the world can afford to do it. Training a frontier model today costs hundreds of millions of dollars and requires tens of thousands of specialized chips running continuously for months. That is why the AI race is being run by the biggest tech companies on Earth and not by startups. The barrier to entry at the frontier is essentially the GDP of a small country. And here is the part that should genuinely make your brain hurt a little. Just by getting really good at predicting the next token, trained on enough text, the model ends up learning things nobody explicitly taught it. It learns grammar. It learns facts. It learns how to write code. It learns how to reason through math problems. None of that was directly programmed in. It all emerged from one simple objective: applied at an enormous scale. That emergence is what makes large language models so surprising, even to the researchers who build them. Now let's talk about the context window, because this term gets thrown around constantly and almost nobody explains it clearly. The context window is the model's working memory. It is everything the model can see at one time. Your entire conversation, any documents you have shared, the instructions the app has given it behind the scenes, all of it. If something falls outside the context window, the model has no access to it. It is not stored somewhere waiting to be retrieved. It is simply gone. Early models had context windows of around 4,000 tokens, roughly 3,000 words, maybe a few pages of text. Models in 2026 can handle context windows of 1,000,000 tokens or more. That expansion is one of the most significant technical advances in LLMs over the last few years, and a big reason why these models have become dramatically more useful so quickly. But there are things LLMs genuinely cannot do, and understanding why helps you use them better. Because the model is predicting the next token based on patterns in its training data, it does not actually verify whether what it is saying is true. It generates text that looks like the right answer. Usually it is. Sometimes it is not. And when it is not, the model says it with exactly the same confidence as when it is. This is what people call hallucination. It is not the model lying. It is the model doing its job, producing the most plausible-looking next token, without any mechanism to check whether that output is actually accurate. That is a fundamental characteristic of how these systems work, not a bug that gets patched in the next update. The model also has a training cutoff. Everything it knows comes from text that existed before it finished training. It does not browse the internet in real time unless it has been given a specific tool to do that. Ask it about something that happened last week, and it either does not know, or worse, it confidently generates something plausible that is not accurate. The context window handles your conversation, but the underlying knowledge is frozen in time. So why does any of this matter? Because large language models are the foundation that everything in AI right now is built on. ChatGPT, Claude, Gemini, Copilot, every AI writing tool, every coding assistant, every customer service bot, they are all LLMs at the core. And increasingly, they are not just answering questions. They are being connected to tools, memory systems, and real-world software to take actions on your behalf. That is what people mean when they talk about AI agents. The LLM is still the brain, but now it has hands. The shift that is happening right now is that LLMs are moving from being tools you talk to into being systems that take action. Early LLMs just generated text in response to a prompt. The next generation of AI products connects that text generation capability to real software, your calendar, your email, your code editor, the internet. The LLM reads a situation, decides what to do, calls a tool, reads the result, decides what to do next. This is what people mean when they talk about AI agents. The LLM is still doing the same thing it always did, predicting the next token. But now, those tokens might be instructions that trigger real actions in the real world. Understanding that the foundation is still just next token prediction, even when the system is booking your flights or writing and deploying code, tells you a lot about both the power and the limitations of where AI is heading. So to recap, a large language model is a neural network trained on a massive amount of text to predict the next token in a sequence. It learns language, facts, and reasoning as a side effect of getting extremely good at that one task. It processes your input as tokens, chunks of text converted to numbers. It has a context window, which is its working memory, everything it can see at once. And it has real limitations. It does not verify facts, it can hallucinate, and its knowledge is frozen at a point in time. What it does by pattern matching at an almost unimaginable scale. Not by thinking, not by understanding, by predicting, over and over again, what comes next. If this video gave you a clearer picture of what is actually happening inside these models, hit subscribe. Every week, we break down something in AI that matters and explain it clearly. Next up, why does AI make stuff up? We touched on hallucination in this video. Next, we go deep on exactly why it happens and what it means for how you use these tools. See you then.